gentlemen. I would just take you through the presentation, try to close it in 15 minutes. This is a small introduction about us, but when you look at this, our introduction, it starts from 1967 till 2024, where it is. So I would just tell you the story behind it. In early 1970s, where India embarked a significant phase of industrialization, steel industry was regarded as a backbone of our economic development. And particularly under third and fourth five-year plans, India focused on steel industries. However, this sector faced challenges due to inefficiencies and heavy reliance on imported raw material. One such critical raw material was graphite electrode. And this graphite electrode was essential for electric arc furnace used in production of steel and ferrous alloys. These electrodes were predominantly imported from USA and Europe. In 1965, Bangur Group, wherein they were primarily engaged in the business of jute, they recognized this gap and took a bold step to venture into manufacturing of graphite electrode in collaboration with Great Lakes Corporation, USA. They established India's first graphite plant at Durgapur, and by 1967, the production of graphite electrodes started in India. Thus, the Indian graphite electrode manufacturing started, and it only reduced the country's dependence on import, but also positioned us as pioneers in this field. Now, coming down to our division, which is impervious graphite equipment division. In 1980s, there was a transformation era in chemical industries in Gujarat, characterized by rapid industrial growth and increasing foreign collaboration. The cities like Vadodara, Ankleshwar, Vapi evolved into key chemical and pharmaceutical hubs. The region also witnessed a surge in small and medium-sized enterprises, particularly in Vapi and Ankleshwar, contributing significantly to the state's ecosystem. As the chemical industry expanded, the demand of specialty alloys, non-metals, particularly used in corrosive application, also emerged. The need of graphite emerged as a preferred material. However, India lacked the domestic manufacturing of equipment-grade graphite. So, recognizing this critical gap, we began developing the equipment-grade graphite in India. And in 1983, we collaborated with Vicarb SA France and established an integrated facility of manufacturing graphite heat and mass transfer equipment in Nashik. Many of our veterans sitting in this room may recall the challenges in the era, how importing of graphite equipment required. They used to publish the requisitions in the import-export bulletin, securing the clearances and navigating the lengthy processes. We remember responding to this need, offering import substitution to the domestic solution. Today, we are filled with gratitude and we witness the growth of our customers, many of whom who have started humbly their journeys during 1980s and have since then expanded globally, contributing to India's industrial reputation. It brings us immense pride to see that India is growing and knowing that every steel structure and every thriving chemical plant, there lies a yet vital contribution of Graphite India, whether in the form of electrode and in the piece of equipment which supports the progress. Further, coming down to 2002, consolidation of our group took place, and it came under the name of Graphite India in 2004. In 2004, we took a company in Germany known as Kova, and further our existence, we started out of India. From 2018 onwards, we ventured into new business like graphene, EV and traction batteries, solar and wind power plants. These are our business verticals. We are into graphite electrodes, we are into impervious graphite equipment division, we are into GRP pipes, we are into calcinated coke, we are into Pomax steel division. There is one more division which we are not mentioning here, that is our specialty division. It is basically associated with defense-related products. So today we have supplied many of these products, and these are working fine in defense and DRDO and ISRO organizations. This is the details of my impervious graphite equipment division. We are into heat and mass transfer equipment and turnkey systems. We are having our own thermal process and mechanical design and process automation. We have various certifications like ISO 9001, 45001, 50001. We are the only company in Southeast Asia having ASME U stamp for graphite equipment. We have having NB National Board stamp. We are pursuing our ISO 50001 TUV NOD certification. EcoVadis is generally awarded as a commitment badge in recognition of sustainability achievement. Now coming down to, I'm just going to take you through the impervious graphite as a material of construction. So this graphite, which is used in material of construction of equipment, it is basically a synthetic graphite. It is not the graphite which is made in mines. So graphite rods and blocks are produced by the process known as extrusion, or there is another process known as molding. Graphite India is into both, into extrusion as well as molding. The raw graphite after manufacturing is porous in nature, hence it is needed to be impregnated to make it impervious. This material comprises around 90% of graphite material and balance resin which fills with the pores. These are some properties of graphite. I would just go through it. Now coming down to graphite as a choice of raw material. So graphite is having a highest thermal conductivity as you compared with silicon carbide, tantalum, stainless steel, zirconium, and other alloys. So this makes it a choice of a graphite for making of equipments. This is most important. We manufacture graphite, so we know the recipe to manufacture equipment graphite. So equipment grade graphite is different than the graphite electrode. In graphite electrode, the electrical conductivity is the major concern, whereas in equipment grade graphite, thermal conductivity plays a major role. So herein, I am just going to show you how the graphite is produced, and we have this plant in Durgapur as well as in Nasik. The basic ingredient of graphite electrode is petroleum product. It is known as coal tar pitch and coke. It is known as calcinated petroleum coke and coal tar pitch. They are mixed together. They are firstly separated, they are blended together, and they are heated into mixture. In the mixture, the temperature is increased up to 800 degrees so that the homogeneous mixture takes place. Further, then it goes through the extrusion machine, wherein the different shape of the graphite is given. It is either circular shape or square shape. Then it goes, that temperature is cooled down so that the mass takes its own shape. Then it goes to the baking, wherein the temperature increases up to 1000 degrees. Now here in this mass, it starts cooling and a carbon formation takes place. So as the carbon formation takes place, we again do the re-impregnation with coke or coal tar pitch. And we try to improve the carbon formation and the mass of carbon. We do this until and unless we find that there is 90% plus more of mass and less amount of gases. Then the major process takes place that is known as graphitization. This is the most important process. Herein, the graphitization takes place from around 80 degrees to 3000 degrees. The temperature is gradually increased by 1.5 degree per hour. And it is then gradually cooled down after achieving 3000 degrees. It is gradually cooled down from at 1.5 degree per hour. So this is a big process. It takes around 4.5 months to make a graphite rod. We are having various ovens to make this graphite rod at our Durgapur and Nasik plants. So during this process of baking and graphitization, there are volatile gases which comes out, and they make the graphite. They make the graphite, impervious. They give certain amount of pores. So how the graphite has to be recognized, and what are the properties of graphite you have to take care of. So these are typical properties of graphite, wherein density should be around 1.8 to 1.9. Thermal conductivity, which is the major thing which we have to see when you buy a graphite equipment. It has to be more than 170 up to 213. This helps you a lot. Second is tensile strength, then flexural strength, compressive strength, coefficient of thermal expansion and permeability. Now, general suitability of graphite equipment, it is suitable at 1.5 times of that of tensile strength. So whenever you take a graphite equipment, you ask them that, boss, please give us a certificate wherein you can see all these things, wherein the tensile strength and the compressive strength is 2.5 times of that of tensile strength, and flexural strength is 1.5 times. The graphite can be tested in various labs in India. In any IITs, you can get it tested. Second is coefficient of thermal expansion, then thermal conductivity. So our graphite material is fully graphitized, and it is made with mixed grain size. So it is having a highest coefficient of thermal expansion and thermal conductivity. Now coming down to permeability, it is ability of material to allow to fluid to the pass. So when you go, there is a, as per ASME UIG requirement, 10 raised to 6 centimeter square per second is the permeability required. Whenever you buy any graphite equipment, you make sure the permeability matches to this standard. Now we have got the raw graphite, the graphite which is manufactured into rods. Now it comes down to manufacturing of graphite equipment. So this is a small process of graphite equipment manufacturing. We get graphite into rods. Further, the machining is done. After machining, there is the impregnation done with, you can see PTFE, as well as phenolic impregnation is done. Then every component is tested. Then the assembly of graphite is done. It is again tested, and inspection and testing done. Further, it goes to the dispatch. So this is how the graphite equipment is made from raw graphite. So initially we have seen how the raw graphite is made. Now we have seen how from the raw graphite the equipment is made. Again, impregnation is the process which is very important here. It takes around 1.5 months to get the graphite impregnated. We have to make sure that there are no pores into the equipments. So this is a list of chemicals which is recommended for impregnated graphite. And these are list of chemicals which are not recommended. So you can go through it. These are the sectors and applications of graphite. It is used in chloralkali. It is used in pharmaceutical intermediate. It is used in agrochemicals and pesticides, phosphoric acid and phosphate fertilizers, chlorinated organic and specialty chemicals, steel pickling, and then batteries and gelatin, polymers, rayon, dyes and intermediate. So these are just some advantages of Graphite India. We are the only company having integrated manufacturing facility of graphite, extruded graphite as a raw material. We are only company which is having in-house phenolic resin manufacturing and cold storage facilities. The equipment quality is maintained from raw material of manufacturing. So this equipment graphite, we are having 50 years of legacy to manufacture the raw material. We are having our own thermal process and mechanical design and plant automation under one roof. I would just go through this fast. We are having multiple DHD machines, PLC controlled impregnation process, then qualified cementing technician as per ASME Section 8 Division 1 UIG. This is most important thing which you have to see when you buy a graphite equipment. What kind of cementing is done? Is the technician's cementing technician has been certified or not? So you can question to any graphite equipment manufacturer that do you have a qualified cementing technician to do the cementing process of graphite? Because graphite is, as the welding is done in steel equipments, graphite is, cementing is done in graphite equipments. I would just go through this. Every raw material or every graphite which is manufactured, it is having a number for traceability. Graphite brings comet material. Every graphite which is manufactured in our plant, it is having a number. So strength properties of impregnated graphite are measured. We have in-house permeability testing. This is the only company we are having in-house permeability testing. A micrographical analysis of pores of graphite has to be done after every 3 months, since we are the only ASME certified company. Now, impervious graphite, there are certifications for impervious graphite. If you can see, there is 21 CFR 175-300 of US FDA. If you are using graphite in any API, or if you are using graphite in any pharmaceutical application, this certification is needed as per US FDA. Impervious graphite is graded by measurement of temperature, that is G22-185, G22-204 for graphite block type heat exchangers. These numbers you have to note it down, as whenever you buy graphite equipment, you can ask to any vendor, do you have this certification or do you have these numbers? This would help you to take genuineness of graphite equipment. Then our engineers are qualified as per ASME Section 1, Division 8, and we do positive pneumatic testing and helium leak test wherever necessary. Helium leak test is most important in graphite application, wherever it is used for pharmaceutical application, as well as into the application which gives out gases. So we are having that facility. We are also having after-sale service. We have around 13 engineers who take care of after-sale services. So thank you very much.